So I'm just gonna do this thing quickly. We're just gonna run through some settings over here. My apologies, should have been prepared with that beforehand. Let's just do fit width. There you go. Okay, now the reason I've actually selected an A5 format is because if those of you who want to purchase these notes separately, I'm gonna leave a link on the YouTube videos at some point in the future, which would allow you to purchase the notes in case you want to have a look at those as well, the printed out versions of those. But anyways, without further ado, let's start. So we're going to be doing basic algebraic equations and functions, and I'm working through a textbook over here for those of you who want to follow. I'm using the textbook C1, Core Mathematics 1. It's the Edexcel AS and A-level modular mathematics. It's by Pearson. Sorry, my apologies, the screen has just gone off. Okay, right, so we're going to try avoiding that. But yeah, it's the Pearson Company C1 Core Mathematics Edexcel AS and A-level C1. So that's the book that I'm using. Now, the book that I actually have is about, wow, this is about 8 or 9 years old. So things might have changed, but the core principle remains the same behind all of the chapters and the ideas and topics that we're going to cover. So for those of you following along, hopefully you'll find an interesting twist to it. If you have the same questions within your current syllabus books, then by all means, it's good to have someone to work through with. So that's what I'm here for. Don't forget, you also have the YouTube website where you are able to comment and let me know what you think. Now, I'm not sure what has happened here, but I'm just going to try to... I feel like the stream has just cut out. So what we're going to do is we're going to try to have a look at that. My apologies, people. My apologies. So we share, copy the link, and paste it onto here. Paste and go. Okay, so yeah, it seems like the stream has been interrupted. What I'm going to do is I'm going to restart the stream. Do apologize for that. Okay, so we're back in the stream, and yeah, sorry about that. I would have literally just started writing on the board before I would have verified that everyone's watching. So, but anyways, like I said, we also have a chat. I'm just going to type something in. Hello. And if you want, you can follow along. You can drop me some comments if you have any questions that you're slightly unclear on. Just remember the number of the question. I'm going to write in the numbers. And yeah, if you have any questions, just let me know. Okay, let's begin. So we're going to call this, let's just call this C1, C1 algebra. And I'm not gonna make multiple notebooks. I'm gonna follow through the same notebook for the rest of the sessions as well, for those of you watching. Okay, right. Time to start. I think we've had a solid 10-minute introduction. Introduce myself, introduce the basics, gone through the entire thing. Let's just get on with it. Okay, so we're gonna start by simplifying expressions. And simplifying is spelled with an I. Okay. Let's see if I can change the color. Alright, have it over there, of course. Okay, so I'm going to start writing in blue. Actually, blue and blue might be a little bit conflicting. Just do it in the dark blue, that actually makes more sense. Okay, simplify these expressions So I'm just gonna write it as 1. That's a little bit too thick. Cool, get rid of pressure. Awesome. Right, so we have 4x minus 5y plus 3x plus 6y. Now the purpose of doing this is so that we can get a simplified expression, and that basically means we're supposed to group all of the like terms. So if I rewrite this, it could be written as, which would imply 4x, and surprisingly this doesn't equal anything because it's not an equation, it's just an expression. So 4x plus 3x minus 5y plus 6y, and now that would also equal, now this is where it becomes an equation essentially, because that equals, let's see, well, it's not exactly an equation, it's an simplification, which basically say that this side also equals that side, and that would be, so you have 7x plus y, and we don't write the 1 because, well, we don't write the 1. Okay, number 2, 3r plus 7t minus 5r plus 3t. Okay, now carrying out a similar strategy, we have 7t plus 3t, you have minus 5r plus 3r, which then equals 10t minus 2r. Simple. Everyone following through? Good. Number 3. 3m minus 2n minus p plus 5m plus 3n minus 6p. Now in this equation we have a total of 3 different terms. We got m, n, and p, and we have to try and simplify, we're trying to simplify the expression. So yeah, same as before, we have 3m plus 5m, and let's do minus 2n. It's a small case n, not a big case. Yep. Sorry, not uppercase, my bad, not lowercase. It is lowercase, not uppercase. Okay, so you have plus 3n, you have plus 5, no, we've already done m, haven't we? That's correct. So we do minus p minus 6p, and that equals, let's see, that would be 8m plus n, and you have minus 7p. Okay, now of course, like, it's easy to follow through in these equations, but once you have equations that start spanning multiple different lines, and once we get into doing algebraic equations and trigonometric equations, like the bigger ones, talking about quadratics and others, stuff like that, you might get many multiple lines. So the way I like to do it is I always like to highlight the answer, so that regardless of what's written on there, if it just makes it easier to see the answer right at the end. Okay. Yeah, cool. Number 4, 3ab minus 3ac plus 3a minus 7ab plus 5ac. Okay, this is where it starts to get a little bit interesting, and we're going to try to sort of group the equations based on the like terms. Okay, all right, so that's what we're doing. If we take a look at this entire equation, the common factor that is in all of these terms is the letter a. So what we're going to do is we're just going to take a out of the equation, and we're going to look at it in a different way. Okay, So we have A that's outside, and we have 3B minus 3C plus 3 minus 7B plus 5C. It makes it a little bit more manageable. And now we can go ahead and simplify this equation, and we are left with A on the outside again, and we have, let's see if we can get a positive term at the first. All right, so we have 5C minus 3C, which leaves us with 2C, and then of course we have a negative term, which is B, so you do minus, what is this, 4B, minus 4B, and we're just left with plus 3. Okay, minus 4B plus 3, and we close the brackets, and I believe this is simplified. Yeah, absolutely. So we're just gonna do the 2 signature underlines over there. 5, it's moving on. 7x squared minus 2x squared plus 5x squared minus 4x squared. Now this again, if you take the rule, you can get confusing equations like this all over the place, especially when you have multiple terms written in the same equation. But it can become easier to focus if you just take out all the like terms that all of these ones share. Remember, you can only do that if all of them share the exact same equations. You can't do it if, if only 2 or 3 of them share the same factor. Sorry. So if you take x squared out, we have x squared on the outside, and we're left with 7 minus 2 plus 5 minus 4. Okay, seems reasonable enough. And we are then left with, what was it called? 5, 3, 7, 10, minus 4, 6. So we're left with 6 x squared. Sorry, that's a cubed, and that's squared. And just to confirm, so we have 5 remaining over there, you plus 5, that's 10, minus 4, 6. 6x squared, final answer, lock it in. 6. Now, if you notice, this workshop carries a pretty much straightforward format. We're literally just trying to power through as many questions as we possibly can that relate to this specific topic. And if you're here for the next time, there will be more equations that we will just basically be solving. M squared n plus mn squared minus 3mn squared. Okay, so this is that kind of equation that I'm talking about. Because you have m, which is common in all of them, and you also have n, which is common in all of them. So if you take out mn on the side, we are left with, for that one, we're just left with 4m, because one of m has been taken out, n has been taken out, we're left with 4m basically, right? And you're plus 5n minus 2m plus n minus 3n. I believe that does it. Okay, cool. And yeah, we can further simplify that by grouping the like terms as such. So we're left with mn on the outside again, and we have 4 minus 2, which is 2m, plus 6 minus 3, which is 3n, plus 3n, absolutely. Okay, and that's our final answer. What we can do is we can just lock it in. Perfect. But if you were trying to simplify things, it would possibly be better to leave it in a single string format rather than this, because they're asking you to simplify it completely. So essentially, if I write this as 2ac minus 4ab plus 3a, that's exactly the same as that, hence the equal sign. But if I was to write it as that because they've asked me to simplify the expression, then it would be much more beneficial. But you can leave it as, I suppose, it's better to leave it as this. It's better to leave it as this. So that'll probably be right. Now it's not fully simplified because it's still in a factored format. So, you know, hence the underlines. That's definitely wrong. What we got to do is we got to turn this into equals 2m squared n plus 3mn squared. Now that is the final answer. But I'm just going to leave it at that for now. Okay, moving on to the next one. So we are on number 6. How do you fit with? Cool. Awesome. Right, moving on to 7. We have 5x squared. 5x squared plus 4x. 4x plus 1 minus 3x squared plus 2x plus 7. And my apologies if I'm mumbling through this, but yeah, it's just the way that I work in terms of maths. But hopefully as I'm mumbling whatever I'm writing, you're able to actually see it on the screen as well. And if you're not, you can always drop me a message, say something on a text. I'm always keeping an eye out for that as well. Okay, so grouping the like terms, I think by now we should be able to just sort of look at the equation and we're like, x squared, x, 1, 7. So we can probably do that in our heads. If we do 5 minus 3, we end up with 2x squared. And if we do 4 plus 2, we end up with 6x. And if we do 1 plus 7, we end up with 8 plus 8. And for now, that is absolutely the equation. Appreciate it. Now, if somebody was to ask you to solve for x, that would come under quadratics. And that's a completely separate bit, which we will probably go through and in the workshop, because I just want to follow the book and I just want to go through the exercises one by one. For now, obviously, I'm not entirely sure how the structure of my teaching, the workshop, how it would change over time. But for now, I'm just going to go through the books. But I believe that they're not asking you to solve for x. So this is as simple as this equation gets. So we're just trying to make it simple. 8. Oh, we're just trying to make things simple. Should be like the slogan of this program. We're just trying to make things simple, you know. 12. Plus 3x squared minus 7x plus 11. Okay. Again, we're just looking at the like terms. So we get 6 plus 3, which is 9x squared. And we get 5 minus 7. You get minus 2x. And you get minus 12 plus 11, which you end up with minus 1. Okay, and we're just going to mark that as the answer. Okay, 9. So you got 3x squared. Your minus 5x. Plus 2 plus 3x squared plus 2x plus 7. Ooh, that's not the right one. So you got 5x plus 2, 3x squared minus 7x. Right, so I think I mixed up the equations from before. Right. So you got 3x squared minus 7x minus 12. Now, that's another thing, you got to keep an eye out on the book as well, because sometimes equations from before are going to look very, very similar to equations from afterwards, and you just have to be careful, because you had I had a plus 3x squared over there, minus 3x squared over there. So yeah, things happen. It doesn't matter. Okay, as long as you get it right, always double check. And if you feel like you still have any doubt, triple check. So you get 3 plus 3 makes it 6x squared. Minus 5 minus 7 makes it minus 13. Ooh, minus 12x. Very close. You get plus 2 minus 12 makes it minus 10. Yeah, that's been done right. Okay. And that's the answer. Pardon me, having a bit of an allergic thing going on in my nose. Should be alright though. Cool, number 10. 4c squared d. Well, I don't think a squared has been written properly. D. 4c squared d plus 5cd squared. And yeah, minus c squared d plus 3cd squared plus 7c squared d. Okay, so we're going to take out c and d all over again. So you just put c and d on the side. Amazing. Yeah, and we're left with 4c, I believe, plus 5d minus c plus 3d plus 7c. Close the brackets. And, yep, put it in the next one. So we have c over there, d over there, c over there as well. So you have 7 minus 1, 6 plus 4, 10c. And we're just going to sort of abbreviate that all at the same time. Let's try not skip steps. You know, I'm being a little bit too lazy. CD, and you got 10c, okay, plus 8d. Okay, and that is equal to 10c squared d. Always be careful of that, okay? Plus 8cd squared. And that is your answer. Yeah, I suppose. This is definitely the answer. Okay. 10 and 11. Well, that doesn't... Remember, we're not trying to solve for C or D. We're just trying to simplify the equation into the most simplest format. And of course, it depends later on when you start actually doing maths. Not that this isn't maths. I mean, this is basic maths. You need this every day. Every day you need this. Okay, 11. Moving on to 11. 2x squared plus 3x plus 1 plus 2. Hey, we got braces 1. Cool. 3x squared plus 6. Awesome. And the first thing is, of course, I'm going to try and... Right. We're going to try and simplify this equation first, of course. And that would turn... You would then basically sort of try to simplify it, and then, yeah, we'll see where it goes. So we're just going to bring it down the same. 2x squared plus 3x plus 1 plus 2 times 3 is 6. 6x squared plus 12. Reasonable? Okay. So now we have... three different terms. I appreciate that. Cool. Yeah, so bringing it down, we have 8x squared plus 3x, lonely x, plus 13. I think that was a little bit rude. It's not a lonely x, it's 3x. That's the answer. Moving on. 12. 4a plus a squared b minus 2a plus a squared b. Okay. Okay, now I'm going to use this equation to show you guys a feature that we're going to be using in the future. Well, the feature that I'm going to be using in the future presentations to actually verify whether I've done the right steps to actually give you the correct answer. Because right now I'm going through the entire equations and, well, you don't know whether I've given you the right answer or not. And frankly, I haven't double-checked the answers as well, because I kind of have faith in the way that I carry out my math. But when things start to get a little bit complicated, being an engineer, I've realized that, you know, it's always best to double check with, you know, others. And of course, since we live in a computer age, others sort of, their working skills have been transferred over to the computers. So I'm going to show you a feature that I'm going to be using for this, for the purposes of just double checking the answer. Yeah, I'll show you that in a minute. But we're gonna go through this working sort of. We're gonna go through the presentation, the question over here, and then we're gonna compare it with the answers and see what the computer has to tell us about the answers. Okay, cool. So we get 4a. We're gonna expand all of this, by the way, just in case you missed it. Okay, plus 4a squared b minus 6a minus 3a squared b minus multiplied. Oh. Okay, right. So we have that over there. Now we have two different terms. Correct, absolutely. If we take out a all the way, you'll still end up with two different terms. So I don't want to waste time on that. It's simple. We're just gonna do this and that, and then this one versus that one. Okay, cool. So we get 4. Oh, right, no, I'm sort of solving it now. So it's a negative term. No. Right, I'm going to go with that one first. So a squared b, because it's 4 minus 3 gives you a squared b. And you get minus 6, 4, which gives you minus 2a. Okay, and that will be the simplified answer. Right. Now, let's actually double check that answer. Okay. I'm just going to write this in. We go 4a plus a squared b minus 3 2a plus a squared b. See how this works out. Does it detect it? Does it detect it properly? So you go minus 3 2a plus a squared b, a squared b. Right. Now, I'm not entirely sure if this will actually work, but yeah. So, ba squared minus 2a. That's what we got. That's absolutely what we got. Amazing, right? So that's also called expansion. Tell you to expand something, it's basically simplifying. Well, it's more sort of expanding the terms, even though it might look reduced. It's a little bit weird. But yeah, no, we're basically sort of simplifying the equation. I think simplifying is a much more easier term to use. Okay. So we're just going to keep that in the background for any tough questions that we see. And yeah, we're going to take it from there onwards. Okay, moving on, we're going to go on to 13. Alright, that's how it happens. Cool, 13. Here we come.
Welcome back. How can I help you?
Not sure what happened there. But okay, cool. So, number 13. You have 2, welcome back, 3x squared plus 4x plus 5. Okay, minus 3, that's x squared, minus 2x, 2x minus 3. Okay, cool. So we end up with 6x squared plus 8x plus 10, and you have minus 3x squared. You end up with a plus 6x and a plus 9. Okay, simplify that. We end up with 3x squared plus 14x plus 19, and that is that. 14. You have 7, 1 minus x squared. Whoa, that was way out of order. Plus 3, 2 minus 3x plus 5x squared. Right, back to simplifying, sort of expanding the equations essentially. Yep, so we end up with 7 minus the 7x squared plus 6 minus 9x plus 15x squared. Sounds about right. So 7 minus 15 is 8. 8x squared. And it's probably going to be a minus 9x. Yes, correct. And a plus 13. Am I satisfied with that? I am satisfied with that. I am definitely satisfied with that. Okay, cool. That's the answer. Well, it's not the answer. It's more like the simplification of that extended equation. As you can see, most of them go from being big to small. So that's why calling it simplifying is much more soothing to the ears in comparison to calling it expansion. Which, of course, I mean, in the first part, when we expanded that, we ended up with a larger term. Well, not exactly larger, but, you know, it's not in braces anymore. And people despise braces. 4. I think braces are cool. A plus B plus 3C minus 3A plus 2C. 4A plus 4B plus 12C minus 3A plus 2C. Yep, definitely got that right. Okay, we end up with an A. And I'm just kidding, it's not just a B straight away, but it's a plus 4B. Ooh, we got 4 B's. And kind of looks like my sort of 6th form result, 4 B's, lols. Plus 12C. No, plus 14C. 14C. Okay. Solved. 16. 4C plus 3D squared minus 2C plus D squared. Okay. Again, expansion. First 4C plus 12D squared minus 6C minus 3D squared. Yeah, I'm going to do the D squared first because it ends up with positive. So we end up with a 3, isn't it? So we 9D squared. 9D squared minus 2C. Now, is that 17? 5 minus 3x squared plus 2x minus 5. Now, frankly speaking, I feel like I'm going a little bit too slow, but having a look at the time, I feel like I'm just rushing past all of this. So if you guys are comfortable with the pace at what this is going, then yeah, by all means, don't say anything. But if you're not comfortable, please do say something. Okay, so we got a bit, well, that looks like an S. 5 minus 3x squared minus 6x plus 15 plus 3x squared. Oh, nice one. So the x squared x, they actually get cancelled. Essentially because, well, minus 3 plus 3 is 0. And anything multiplied by 0 is basically like saying how many of x's are there. Well, there's 0. There's basically none. Ooh. So out of the equation. Cool. So we end up with 5 minus 6x plus 15. Ooh. See, skip that on the term. Right, let's do that again. So you get 5 plus 15, 20 minus 6x. Now, if this happens to you, it's always easier to sort of mark them if you have a different color pen. Even if you don't, you can just mark it with that. So you say, okay, 5, that gives 20, that gets cancelled out, and boom, that turns into that. Awesome. Everyone's happy. And that is the answer. Yay. Okay. 17 has been done, tackled, all gone, boom, finished. Let's do 18, and that's that. Ooh, 18 is the last one for that exercise. I don't know, do I want to try and squeeze into that one? No, I think that page is good enough. Cool. Let's go on to the next one. Actually, we don't make that fit with. Those look weird. Okay. We got 18. So we got 18 r squared plus 3t squared plus 9, and you go minus 2r squared, tricky, plus 3t squared, okay, minus 4. Okay, so now that minus basically is there to sort of confuse, I suppose, but if you look at it carefully, you can just write it as minus 1. And what you got to do is you just got to multiply every single term with that minus 1 before you bring it out. Yeah, and then you can just sort of ignore the minus. So if you get, I don't know why do they have that in brackets, because that's literally multiplied by 1. And you basically just remove the brackets, essentially. So you get r squared plus 3t squared plus 9 minus 2r squared minus 3t squared and then plus 4. Okay, and yeah, I'm just going to do the marking technique over here. I don't know which color was it. It was probably that one. Right, so we're going to do with r squareds first, which ends up with minus r squared. I don't like that. No, I don't like that. You know what? Yeah, no, I do not like that. I'm not going to do that. Let's go with the positive numbers first. We go 4 and 9. So 9 plus 4 gives us 13. And t squareds, they just get cancelled because banter. And r squared minus 2r squared gives you minus r squared. And that is that. And I do believe that's the last expression over there that we have to simplify based on this book that I'm going through. Okay, cool. Now we're now going to sort of move into the rules of indices and all of that and whatnot. And we're just trying to sort of simplify things again. See how that works. But yeah, we'll go through that very soon. Now, we're going to go through that in a couple of minutes. I'll tell you what, let's take a 10-second break, or actually 10-minute break. Let's take a 10-minute break, and I'll come back with all of this. If you want, yeah, go get yourself some water. You know, do whatever that makes you feel that you're comfortable and still focused, ready to go. Okay, see you in 10 minutes. Comfortable and still in 10 minutes, ready to go. Okay, see you in 10 minutes. Oh. Okay, hello. Okay, so we're just going to confirm that the stream is actually working before we get back to business. Awesome. Alright, so we're going to move on, and we're going to go on to the next exercise, which is again simplify the expressions. So I'm just going to keep the same number chain going on. So we're just going to carry on with that, and yeah, we'll see how that goes on. You know, the thing is, yeah, let's just carry on simplifying the expressions, because there's a lot of expressions to simplify, to be honest. So yeah, I suppose we could actually hash the entire sort of problems out within the 4-episode section, and if not, then we'll do something about it, 100%. Yeah, because we also have to do equalities, inequalities, go to the quadratic functions, and there's stuff from C2 and C3 that we need to cover as well. So yeah, we'll do some stuff, and we'll figure out how is this gonna progress. Is that L cubed? No, that's 13. We really should be writing that much better. Wow. Okay, 1, 3. Still looks like an I, isn't it? You know what? It's okay. I'm just gonna I'm gonna take the blame for that one. Alright, so we're gonna move on, and yeah, I'm just gonna carry on with the same number chain. 19. Right, here we go. X cubed multiplied by x to the 4. Now, of course, the rules of indices are going to apply over here. Yes, so we're going to use the rules of indices to say that this is also equal to x to the 7. Final answer. Okay, 19, 20. 2x cubed multiplied by 3x squared. What do you guys reckon? What's gonna happen there? It's probably just multiplying the entire thing, isn't it? Yeah. So it'll just be sort of 2 times 3, which is 6, and then x to the 5. Final answer 20. 21. If that's a good number, 21. Okay, 21. We have 4p cubed divided by 2p. Now, this can also be written in a similar manner, where you have 4p cubed divided by 2p. And you just do boom, boom, 2, boom, boom, 2. And it ends up with 2p squared. Final answer. Awesome. Lock it in. 22nd. Me birthday. Where's that going to end up again? So we have 19, 20, 21, 22. Wow. Losing count over here. 3x, too many equations. Minus 4 divided by x minus 2. Oh, by the way, you see what happened over there, right? So, because this was p to the 1, that was p to the 3. And because that was divided, we do 3 minus 1 gives you 2. Similarly, if we do the same thing over here, we end up with 3x minus 4, and then minus 4 minus 2 gives you minus 2. Because the minus is basically you have to multiply it by minus 2. Yeah, it's a little strange. So you end up with 3, of course, and x, again, of course. Of course, x, yeah. X minus 2. And in other terms, that would also be equal to 3 divided by x squared. I'm not sure which one they would ask you to use, but either way, they're both the right answers. So I'm just going to leave it as, let's just leave it at that one. I kind of prefer that one. Okay, 23. Okay, cubed divided by k minus 2. That would give us k to the 5. So you get 3 minus minus 2. Okay? 24. You have y to, that's just 5. This would be equal to y to the 10. And the reason for that is, of course, like you can, it's when it's in sort of, when it's multiplied, you just basically do 2 multiplied by 5. Well, that's the final answer. 25. We have 10x squared, 10x to the 5, divided by 2x minus 3 is equal to, so you get 10 divided by 2, which is 5, and you get x5 minus minus 3, which is x to the 8. 26, let's do 26, and it's p cubed multiplied by 2. I mean, just write the whole thing, damn it, why are you just trying to confuse people? Divided by p to the 4. Which would equal 3 times 2, 6 minus 4 is 2. P to the 2. Final answer. Ooh, forgot to do that. 27. I'm sorry, I couldn't see the answer because it wasn't in double underlines. Oh my god. 27. 2a cubed squared. Well, that's an interesting one because, well, I'll run through it in a second. Divided by 2a cubed, which is equal to, right, let's do this. So 2 divided by 2 is 1, of course, so we're not going to write anything over there. And then, oh, but it's not 2 divided by 2, is it? No, it's definitely not. Let's write this one out because it will just be easy to explain. So, we have 2 squared, and then a cubed squared, if that makes sense. So you go that whole thing squared. So of course you got to multiply 2 by itself as well. So you get 4a to the 6 divided by 2a cubed. And that would give you 2a cubed. That is your answer. 28. Let's see if you can try fit in the last 2 ones as well. 28 would be 8p minus 4. P minus 4 divided by 4p cubed. Right, and that would be interesting how this would work out. Minus 4 minus 3. Right, so that would definitely just be minus 4 minus 3. Yep, so we have 8 divided by 4, which gives you 2p, and then minus 4 minus 3 is 7. 2p to the minus 7. My apologies. You get a minus over there. Which is also equal to 2 divided by p to the 7. Okay, 29. Let's see if we can squeeze this one in, because I'm pretty sure... Oh no, it's a reasonable one. 2a to the minus 4 multiplied by 3a to the minus 5. Yeah, everyone's following. The YouTube video is still going on. Boom. Is 6a to the minus, because it would be minus 4 plus minus 5, it would be minus 9, which is also equal to 6 divided by a to the 9. They look ridiculously the same, don't they? Yeah, the a's and the 9s. We're just going to have to work that out. Cool. Alright, so that's the answer. We're going to leave it as that. And move on to the next page. Fit with... Okay. That was 29. We got 30. Which is 21. A cubed b squared divided by 7ab to the 4. Okay. And that should equal, so if you do 21 divided by 7 gives you 3, and 3 minus 1 gives you 2, A squared. Yeah, that A looks much not like a 9, unlike the other ones. You get 2 minus 4, which is B to the minus 2, which is also equal to 3A squared. 3A squared divided by B squared. B squared. That's the answer. 31. Moving on. 9 squared. 9x. Now that definitely looks like an A. I need to work on that. 9x squared. Got to be more bold with the 9. It's a 9. 9x squared multiplied by 3x squared braces 3 braces brackets, whatever you want to call it, is equal to 9 times 3, which is, top of my head, I'm probably saying 27. 27. I know, that's slightly bad. Should be 9 times 3 if I'm doing a YouTube course on doing maths. But I don't. What are you going to do? Right. Okay, 3 times 2 is 6. No, actually, I do know because it is 27, but no, seriously. X is 2 plus, let's multiply it. 3 times 2 is 6, plus 2 is 8. That is the final answer. 32 is 3x cubed multiplied by 2x squared multiplied by 4x to the 6. It's a little bit too much. 4x hexaxed. Hexared. I don't think that's a word, but no, it's to the 6. It's much easier to pronounce. 4 times 2, 8 times 3 is 24. 8 times 3 is 24. 8 times 3 is 24. 24. X 3 plus 2 plus 6 gives you a total of 11. X to the 11. Yeah, I should be writing that as 1 and 1. I definitely did not make it easier to read it, so I'm just going to write 1. X to the 11. Boom. Everyone writes differently, you just have to keep up. It's cool. Hey, you guys might be writing something weird that I don't really completely understand, but again, you're not teaching, so, I mean, you're not doing the YouTube video, so, again, I gotta keep in mind all of this stuff. Anyways, let's carry on. 7A, I'm saying anyways way too many times. Yeah, the math is definitely taking a toll. Like, I don't think I've done this much math in a long time. Scary coming out of an engineer's mouth. Probably not. Whoa, that's a statement right there. Is equal to 7 times 3. No, that's not 7 times 3. It's 7 times 3 times 3. So it's 21 times 3. 21 times 3. Come on, guys. You should be knowing this answer. It's 63. Definitely need that. 21 times 3 is 63 because you have 7 and then 3 times 3, which is 3 times 3 is 9. So 9 times 7, 63. 4 added, so 4 plus 4 times 3 is 8. So 4 plus 8 is 12. You have A to the 12. That's the answer. 34. Four y cubed, whole cubed, divided by 2y cubed. Excuse me, I'm having some sort of dust allergy. I'm not doing well with like polyester stuff, and I'm currently wearing like a polyester thing. My bad. Anyways, moving on. So you have 4 cubed. Ooh, what is 4 cubed? Yeah, 4 times 4 is 16 times 4 gives you 4. 4 times 6 is 24, so it'd be 4 plus 2, which is 6 times 4. Right, you know what, I'm just going to do it. I'm just going to use a calculator. Not ashamed. I'm slightly ashamed. Let's see if I can actually guess it, though. 4 times 4 is 16. 16 times 4 should be... It should be 64. Oh my god, it's binary. How do I not know binary? Let's do it. 4 times 4 times 4 is 64. Thank you. You saved me, calculator. You saved me today. Yes, you definitely saved me. Oh, but that's not it. Right, so 64 times 2, 128. Did have the top of my head, 100%. Yep, 128. 128, and then you have y, which 3 times 3 is 9, divided by 3 minus 3, which is 6. That is the answer right there. 35. This is the answer to sort of simplifying, FYI. It's not something that we just do now, the arrow. Right, 2a cubed divided by 3a squared multiplied by 6a to the 5. Okay, now there's two ways that you can actually go about it. You can actually go about it the normal way, which is just sort of, 3 minus 2 plus 5, which gives you sort of plus 4. And that sorts out the a, but it doesn't sort out the division bit. So the way you can do that, actually, the indices actually can work there, because you get 3 minus 2 plus 5, which gives you 4, 100%. But the division bit, you always got to do division first, then multiplication, then addition, if there is any addition, subtraction, and so on and so forth. But if you have brackets, do the brackets first, and then follow the DMAS within the brackets as well. So following that step, so you got 2 divided by 3, which is 2 divided by 3, multiplied by 6, and that basically turns into 4. Yeah, because like 3... It's basically 2 multiplied by 6 divided by 3, essentially. So because we have 6 over there, 3 divided by 6 gives you 2, and 2 times 2 is 4, which is equal to 4a to the 4. I'm putting my money on that. Is that a bit too complicated? Yes. Let's find out the answer. Yes. Just delete all and do 2a cubed. Why isn't it alright? 2a cubed divided by 3a squared multiplied by 6a to the 5. 2a cubed, 3a squared, 6a to the 5. Let's see what they come up with. Evaluate. Oh no. I did something wrong. Wait, how on earth did he get 4a to the 10? Let's have a look. Oh, what? Hmm. What are they talking about? Seriously? Add 2 and 5 to get 7. Good Lord, this is actually wrong. I'm starting to unbelieve in this application. Oh my God. Oh my absolute God. This is absolutely wrong. Oh my God. Well, either way, even if they were doing the multiplication first, you would still end up with the a should be down there, shouldn't be in the middle. That is so weird. What? Yeah, no, somebody messed up the result on the platform. So I'm gonna raise an issue on that. That is definitely wrong, 100%. Yeah, that evaluation term should not be 4a to the 10. Come on, their solution doesn't even make any sense. Let's be honest. Multiply the powers of the same base and their exponents. Add 2 and 5 to get 7. Add 2 and 5 to get 7. So you got 2 over there plus 5 gives you 7, which they said over there. That's fine. express 2a cubed divided by 3 as a single fraction. See, no, that it's not divided by 3 braces. But even if it was, no, actually, no, it's not 2 divided by 3 braces. But actually, you could write it as that, couldn't you? That is so weird. Wow. Okay, so what they've essentially stated in there is that they have written this 2a cubed, which is divided by 3, and they put that into brackets. What? Who does that? A squared multiplied by 6a to the 5. They put that in brackets. Okay. And they've basically gone ahead and said, that's actually really funny. Okay, so they've said that you get 2a cubed divided by 3 multiplied by 6a to the 7. Oh, good lord. Wow. I mean, that literally does not make any sense. And yeah, if they do that, then you get 2, and that would equal... Oh no, so you don't get 2 over there. My apologies. You get a 2 over there. Right, and that equals... 4a to the 10. Which is wrong, because you need to follow the simple rules of D mass, or bod mass, right, whatever you want to call it, because you would have to go 2a cubed divided by 3a squared multiplied by 6a to the 5. And because 3a squared and 6a to the 5 was not in brackets, they don't both end up at the bottom, but that's how that should work. And then you do that, which ends up with 2, and then that would equal, 4a to the 8. What? Oh yeah, 8 minus 2. 8 minus 2, 6. Did I do something wrong previously? Because I did 3 minus 2 plus 5. Oh my god, it was 3 minus 2 plus 5. Yeesh. Well, I got it wrong. I got something wrong. That's definitely wrong. That is also wrong, right? This is supposed to be 4a to the 8. Nope, to the 6. My apologies. So you go 5 plus 3 minus 2. 4a to the 6. That is the right answer. That is not the right answer. And neither is that the right answer. Wow, I cannot believe such a simple question can have such adverse effects. Like, that's pretty funny. Oh my god. Okay, well, there's something wrong on this. And no, this result was definitely not useful. This is a wrong result. Please see my website. No, I'm just kidding. No, but seriously, it's a wrong result. Okay. Yeah, I actually can't believe they actually said that was the answer. That's pretty funny. Wow. All right. I'm just going to go back, and I'm possibly not going to use this application. Actually, using this application is rather simple. I actually helped out a little bit. I'm just going to double check, because like, yeah, if it gives me a wrong answer, I can be like, you know, that's the wrong answer. And let's just mark that in red as well, because that is not the wrong, that's the wrong answer. Whew. Well, one mistake. Everyone makes mistakes. You got to work through. You got to make sure you get it right. You got to understand why you got it right, because that one's wrong as well. That one is wrong. That leads to this is the right equation. Let's mark that one in green so that people know. I did a mistake. I did a serious, it was, well, if I was doing a bigger equation, that would have been a very serious mistake. So you got to keep focus. 36, and we're going to work through that as well, because like later on, when we're actually doing the equations and stuff, you want to find out where you're going wrong and which specific thing. So because it might be that, you know, sometimes I would not be making the right equation and things may happen. So it's fine. Doesn't matter as long as you power through it. 3, whoa. 3a to the 4 multiplied by 2a to the 5 multiplied by a cubed, which is equal to 3 times 2 is 6, and a, you know, I still haven't learned from my mistake. I'm doing a shorthand. Yeah, because I mean there's only single sort of operators over here, so hopefully that should be fine. So you get 4 plus 5 plus 3, so gives you 7 plus 5, so gives you 12. 12. Yeah, sounds about right. Okay, so that's the end of the other exercise as well. What we're going to do is we're going to take another break. Yeah, I know, getting tired of this. I'm probably getting sort of a bit worked up as well because I got that one wrong. So I'm just going to take a break, take a cool off. We're going to come back in again. Let's give it 10 minutes. I'll be back in 10 minutes. Don't cool yourself off. Take a little break, come back, and yeah, we'll go through the rest of it. I think 10 minutes is probably a little bit too long of a wait. Let's do like a 5-minute break this time, okay? 5-minute break. Back in a bit. Okay, so I'm back a bit early because I want to let you guys know that the purpose of this... Actually, that's probably not a good idea to do when everyone's not back. But yeah, I'm just going to go through it anyways. The purpose of doing this is just to understand what it's like to work on a paper. As you can see, many people make mistakes, and that's okay, as long as you catch out your mistake and you sort it out. So for example, when I did 3 minus 2 in my head, I got a -1, which is when I added 5, I got a +4, which is why I ended up there. But then when I double checked with the calculator and I actually did it properly, I found out that it's actually 6, not 10 or not 4, or completely random numbers. And I actually, even if somebody told me that it was 10, I actually probably predict, okay, that's probably the working that he did. He did it multiple times, and you know what? I think that's how it is. But I don't think that would have happened unless there's brackets in there. If this would definitely be equal to this. If it was this equation over here, where is it? Yeah, so if it was this equation, then that would be correct, okay? But because it's this equation, that is wrong, okay? And this one is correct, rather than that. So yeah, what I'm trying to say is that the purpose of this workshop that we're going through is just to get an idea of what it's like to actually write things on the paper and how long does it take. Okay, so we're just trying to power through, trying to get our math and trying to get it right. Now usually the questions that I'm doing, people are not allowed to use calculators in the first place, so which is why you see me trying my best not to use any kind of calculator unless it's a big calculation or unless I have a doubt, which is why all these equations that we're doing, trying to simplify expressions, they're pretty much basic numbers. But of course in the real life you won't get some straightforward numbers. You can try your best, but you would not get some straightforward numbers in real life. So you should know how to work with otherworldly numbers as well. Usually it's always better to work with fractions and even leave answers in fractions if they're asking you for precise numbers, if you need precise numbers, because later on you can manipulate fractions. But once you get down to a decimal level, the original fraction is lost. Which is, of course, we'll find all of this out when we're working through the workshop and getting in learning how to actually work through the paper. But in addition to that, if you have any questions on how the theory works and how mathematics is supposed to function based on the theories created by the old ones, I run some lecture series as well, and it's always up on Eventbrite at the same time as well. So hopefully, I haven't actually set up one over here right now, but these lectures, they're sort of held in big lecture theaters where you get multiple different people sitting, and yeah, it's just me presenting at the center of that. It's always good to actually get out and see what that kind of a lecture format is as well. And part of the reason of me doing these sort of workshops and starting Simply Learning is so that people can understand the difference between the classroom, where it's just literally people helping you through every single question, and a lecture where you basically go home, you basically attend the lecture, he gives you the theory within probably 2 hours, 3 hours maximum, and you then have to go home and you have to practice yourself, just as we're doing this workshop. We're literally working through every single question, trying to find out how we can get the right or wrong. And then, of course, we have to make our decision whether it's right or wrong. But yeah, that's basically the format of Simply Learning. Well, especially just for mathematics. But of course, as we add other subjects, which we probably would do in the future, we will look at other subjects and we'll try to see what is the best way to deliver each and every one of those subjects. Anyways, we're back and we're ready, refreshed. Hopefully everyone is doing all good. I think I've stretched it a little bit past the the initial 4 minutes or 5 minutes that I said. It's basically roughly 10 minutes. But yeah, let's get this done. Moving on. Expanding and simplifying even more equations. 37, 9, x minus 2. I'll probably say that equals to 9x minus 18. That's the... I forgot to do that one as well. Okay, 38. Before I do that one, is that one actually right? So you got to do 3 times 2, 6, 8, 4, plus 5, plus 3, 12. Okay, that's fine. 4 plus 5 plus 3 is, yeah, 12. Okay, that's good. 38. Xx plus 9 equal to x squared plus 9x. Confident that's right. I think we can squeeze in another one. 39. You got minus 3y. Right, had to be some minuses in there, isn't it? 4 minus 3y. Okay, and that would equal to plus, just why am I writing plus? It's 3 times 3, right, for the brackets as well. So 3 times 3 is 9. Because it's a minus, it turns into a plus. So you get 9y squared minus, because you do minus, multiplied by a positive. 3 times 4 is 12. You get 12y. And that is that one for that. 39. Cool. We're on to, right, with, cool. We're on to, no, I'm not doing that. 40. X, oh, well, that's y. X, y plus 5. It's good to see variation, you know, because people, they always keep questions in textbooks, they always have the same variable over and over again. But it's good to see variation. So x, y plus 5x. Boom. 41. Minus x, 3x plus 5 is equal to minus 3x squared minus 5x. Now, I'm not entirely sure if we can actually get rid of the minuses, because we don't know what's on the other side of this of the equation, if this is indeed part of an equation. So we're just going to leave it as that, and hopefully that's probably right. 42 minus 5x 4x plus 1. This gives us minus 20x squared plus, whoa, that's a minus, minus 5x. Same as before, we're just going to leave it as, why isn't that? We're just going to leave it as minus as it is. Okay, 42, 43. Excuse me. Minus 2x, 5x minus 4 is equal to, let's do a positive, right, because that's minus 4 times 2 is 8x minus 10x squared. That's that. 44. 44. I think I've skipped some questions. Let's run that again. We've done 5x, 4x plus 1. Right, so we definitely skipped questions. Okay, no worries, we'll do that next. You know what, let's erase that. We'll do that one again later on. Okay, erase. Cool. 4x. The reason I had to, I felt like erasing that is because I want to make sure that this sequence remains the same for somebody else who decides to do these questions or watch this later on while referring to the book, of course. 4x squared plus 5x. That's that. And you get 44, moving on, minus 3y, 5 minus 2y squared. You get a positive 6y cubed. I believe that's right. Yeah, you get a 6y cubed. 100%, yeah. And then you get a minus 15y. And that would be right as well. 45 minus 2x, 5x minus 4. I believe we just did this. This ends up with a positive 8x and a minus 10x squared. So also final answer 46. We have 3x minus 5x squared should equal to 3x cubed minus 5x squared. Again, final thing. 47. 3x plus 2 plus x, minus 7, which would equal, right, now this one's a little bit bigger one, so we're just going to take it easy and expand this out. 3x plus 6 plus x minus 7. Okay, and of course the like term over there is, we have two sort of similar terms, and we just say equals 3, no, it's not 3, equals 4x and then minus 1, and that's final. 48, 5x minus 6 minus 3x minus 2, and these ones are in brackets, so that would expand out to be 5x minus 6 minus 3x plus 2, and that would end up being 2x minus 4, and that would be that. 49, x multiplied by 3x squared minus 2x plus 5, which would essentially just be equal to 3x cubed minus 2x squared plus 5x, and that's final. 50, 7y squared 2 minus 5y plus 3y squared is equal to 14y squared minus 7 times 5, 35, y cubed plus 3 times 7, 21, 21 y to the 4, and I feel that's final as well. So that was 50. Let's see if we can do 51 on the same page. We can probably do 51 on the same page. 51 minus 2y squared 5 minus 7y plus 3y squared. Okay, which would equal 10, sorry, minus 10. Is there a positive number there somewhere? I think it's that one's a positive. So you just start it with a positive, which makes it easier to think and to lay it out. So you get 7 times 2, 14. So you got minus times minus, 14 y squared cubed, actually, cubed minus 10 y squared minus 6 y to the 4. Of course, usually you'd put it in descending order because that's how the indices prefer to be. They love being in descending order. But we're going to leave it as that because you can write it however you want, realistically speaking. Alright, moving on to the next one. Which one were we on? 51, so 52. Ooh, this is getting work done. Nice. Being honest, I don't think I've even written this much when I was in high school. Wow. Some good stuff. 52. Okay. 7 x minus 2, that's in brackets, plus 3x plus 4 minus 6x minus 2. Okay, let's expand all of them out. We get 7x minus 14 plus 3x plus 12 minus 6x plus 12. Okay, 7, 3 minus, so you get plus 4. I'm not doing that. So you get 7 plus 3 is 10, minus 6 is 4, 4x. Then you get minus 14 plus 12 plus 12. So that leaves you with 10, I believe. So minus 14 plus 12 is minus 2, plus 12 is 10, plus 10. And I do believe that is the final expansion. 53. 5x minus 3, 4 minus 2x plus 6. So you would end up with 5x minus 12 plus 6x plus 6. And that would end up with 5 plus 6 is 11, 11x, and you get a minus 6. 53, 54, 3x squared minus x times 3 minus 4x plus 7. Now, it doesn't matter what equation you're doing. Always remember, always got to follow these basic steps. That's why practicing these equations is always essential. And, if people who are, who find this a bit sort of difficult to completely, deal with brackets and everything, practicing makes it much easier for yourself on the long run. So, I would recommend practicing as much as you possibly can, whenever you get the time. And it's not just practicing one day and then not doing it the next day. You want to make sure that you practice and you practice. And, even if you take some time off, you can practice like a few years later or a few months later. It wouldn't make a difference as long as you're getting some practice in. Okay, so that would basically be equal to 7x squared minus 3x plus 7. 55. That's 54, isn't it? 54 would be that one. And 55 is that one. 4x. X plus 3 minus 2x. 3x minus 7. Let's expand this out. 4x squared plus 12 minus 6x squared minus 14x. Ooh, 12x. 12x. Whoa, that was so close. Nice, wasn't it? Okay. So again, sort of two terms over there. I'm just gonna, I'm just writing on a new line. Don't want to get too congested. That's a minus. That's also a minus. Interesting. Okay. So you get minus 2x squared. Minus 2x squared minus 2x. Huh. Look at that. There's a lot of minus 2x's and 2x squareds going on over there. 56. That's not good. It's definitely not good. Yeah, let me just finish up with this and then I'll have a look at what's going on. 3x squared, because I've got a lot more lectures to go through. I mean, workshops to cut through. And if it starts lagging like that every time, that's not something I'm happy with. 5x squared, 3x minus 4. 3x, nope, that's not right. Okay, so we have 2 times 3, 6, 6x cubed plus 3x squared minus 15x cubed plus 20x squared. 6 minus 15. We have a positive number there, so I'll just use that. So you got 20 plus 3, 23x squared, and you have minus 9x cubed. And that's final. Awesome. We've been through another 20 questions, I believe. Yeah, that's absolutely right. It's been through 20 questions. We're going to do some more. I'm going to give some time for that. Yeah, we're going to move on to factorizing apparently, so that's good. Awesome. Right, so what we're going to do is we're going to take another 5 to 10 minute break, and I'll see you guys in 10 minutes. Okay, hello, and welcome back. So we're moving on to the next exercise, but yeah, for you guys it'll just be pretty much the same thing. But now what we're going to be doing is we're going to be doing factorization, and factorization is essentially, I presume, it's evaluation, right? 56. So let's go through 57. Yep, that's definitely a little bit much better. Oh no. I think I just went into a song mode. Okay. Yeah, no, we're going to start with the new page, of course, because it's a new exercise. And we're just going to do fit width, lock the screen, cool, so it doesn't do anything dodgy at the point in time. So now what we're going to be doing is we're going to be factorizing. So let's just write in factorize these equations. Factorize these equations. I'm missing a no. Factorize these equations. Okay, let's go. So 4x plus 8. Simple enough. Let's do 4 on the outside. We get x plus 2. Second, 6x minus 24. Gives you 6 on the outside, and you get x minus 4. 3. Alright, I'm not doing the underline thing. Alright, 3. 20x plus 15. Whoa. 15. An odd number. So you get 5 on the outside, and we get 4x plus 3. That's final. Fourth. 2x squared plus 4. Yeah, and we're just going to do same 2 on the outside. X squared plus 2. 5. 4x squared plus 20. And that's 4 on the outside. X squared plus 5. I feel like I'm forgetting the underline thing again and again. So let's see how it goes. 6x squared minus 18x. This should be a little bit more tricky. So I'm pretty sure it's like 6 on the outside with x, of course. And you get x minus 3 on the inside. 7. X squared minus 7x. And this would be x on the outside, and you get x minus 7 on the inside. 8. 2x squared plus 4x gives you 2x on the outside, x plus 2 on the inside. Yep. 9. 3x squared minus x gives you x on the outside, 3x minus 1 on the inside. 10. 6x squared minus 2x gives you 2x on the outside, x minus 1 on the inside. Yes. No. That should be 3x minus 1 on the inside. There you go. 11. 10y squared minus 5y gives you 5y on the outside, and you get 2y minus 1 on the inside. Boom. Okay, so pretty sure that was that 11 or 10? That was 11, wasn't it? Yep, 11. Let's do 12. 35x squared minus 28x. Now in this situation, I do believe there is no common factor because it would be 7. Oh no, 7 is a common factor. Oh, there you go. So you got 7 odd numbers. Honestly, do not like odd numbers. 7x, and you end up with 5x minus what I do believe is 4. Because you get 4 times 7 is 28. 4 times 7 is 28. 4 times 7 is not 28. It is 28, yeah. I don't know, what am I thinking about? Wait, but how can it only be 28? Oh no, it is 28. It is 28, yep, cool. Wow. Had a blank moment over there. Happens, it happens. That's why the breaks are needed, you know, because if I would have just been keep doing this, of course, you know, it's not good. Always take regular breaks whenever you're doing any kind of intense, you know, math, even if it's not intense. For me, this is intense because I haven't done this in a long time. So yeah, take as many breaks as you feel like, and make sure that you're double checking your equations as you go through them, because you know you might end up wrong, and for you it might not be a big deal because some of you might still be at school or university, but if you end up with a wrong calculation in real life, it's just gonna, you know, be quite drastic, because that calculation has something real attached to it, you know, because you probably be making, like, I don't know, you're gonna be making a calculation about something that's vital, and if you get it wrong, it will just mess up the whole thing. So try to stay focused, take regular breaks. If you practice now, of course, it will just be beneficial later on. 3y plus 2, that one. Yay, 15. 4x squared plus 12x is equal to, simplify this one, 4x, and you get x plus 3. I do believe so. 16. 5y squared. And I miss these single line equation, like, you know, solutions, because literally all you need is like one single line, and then you literally end up with the answer that they require. Imagine you're sitting in your boss's office and he calls you in and he's like, well, I want to know what 5y squared minus 20y is simplified. Can you simplify it for me, please? And you go, well, yeah, it's 5y, and there's basically 5y lots of y minus 4, which of course doesn't make so much sense right now. In probably reference, it would make sense, but even then it wouldn't make any sense, because your boss would just be like, well, I just want the numbers, I didn't ask you for your reference, or why do I want the numbers? I do not want to tell you. You just gotta give me the numbers. I don't know who says that. I've never been in the job. It's so funny, man. Okay, so take a common factor, which is 3x and y. And you're with 3y on the inside and 4x on the other side. Yep, sounds about right. 17, 18, see 18, 6ab minus 2ab squared. And simplifying that one, you take 2 on the outside, 2ab on the outside actually. Whoa, that was a wee b. 3 minus 2b. Yes. 18, 19, 5x squared minus 25x and y. That equals 5x on the outside, and you get x minus 5y on the inside. Yes, I did copy it right down. Yeah, cool. Now I do believe we would have a total of 4 that would come on the outside. Yep, 4x y on the outside, and you get 3x on one side plus 2y on the other side. 21, 15y minus 20y z squared. I'm just going to write a z a little bit easier so that people understand it's z, not some Greek alphabet. So 15y minus 20yz is squared. Probably going to say it's just 5 on the outside, 5y on the outside actually. And you end up with 3 minus 4z, right, that have it, z squared. And you know what, I actually like the other z that I was making because it's a little bit easier to read. Doesn't get it confused. Y z squared. Yeah, I'm just going to stick that is not what it is. It's z squared. Yeah. There you go. No mistakes. Nearly had a mistake. Transposition. Always trust your writing. 22nd. 12x squared minus 30. I do believe we have 3 and 2. So 6. Right. So 6 on the outside. And we end up with a 2x squared minus 5. Yeah, 5 times 6 is 30. Okay, 22. Let's just go to the next page. It's a good thing I'm not actually using pages, because then the whole environmental issue would come into play. But over here it's just like, well, I'm not really using any environmental resources except for electricity, which probably people are burning stuff to get right now. But, you know, a little bit better, I suppose. xy squared minus x squared y. Yeah, let's take out x and y, both. And we end up with y minus x. Yes, we end up with that. 24. 12y squared minus 4yx is equal to, it's also equal to 4y on the outside, 3y minus x, I believe. Yeah, that's it. Okay, moving on. 25th question. We have x squared plus 4x. Okay. And this would be equal to x on the outside and x on the outside and x plus 4 on the inside. Yeah, absolutely. 26. 2x squared plus 6x is 2x on the outside, and you have x plus 3 on that side. 27. X squared plus 11x plus 24 is equal to... Oh, that's a quadratic equation, isn't it? You're trying to get you to factorize a quadratic equation. Okay, well, that's simple. Let's do that. So we need to get something that multiplies into 24 and something that adds into 11. I'm probably going to go with 9 and 3. No, that doesn't add up. 9 and 2. No, doesn't add up. 24. It's to multiply into 24, add to give you 11. 6 and 5, no. 4 and 6, yes, no. 2 and 12, yes, but also no. 7 and 3, nope. 8 and 3. Absolutely, yeah. So it's 8 and 3, right? So that would be would it just be, I believe it would be x squared. Yeah, I think it would be x squared plus 8x plus 3x plus 24. Drop it down to the new line. It should also be equal to x plus, no, then x plus 8, and then plus 3, and you get x plus 8. 8 times 2 is 24, yeah, boom. Okay, and that would imply, if you take out the common factor, x plus 8, would give you x plus 3 multiplied by x plus 8. Yeah, this is not promising either. No, but that's definitely the answer. Right. I forgot to tell you. Yeah, that's definitely the answer. Okay, 27. Let's go to 28. (27, 28, 28, so that's what, 24, 28, 27, 28, right. So you got x squared plus 8x plus 12 is equal to, so I'm not having a look at the actual YouTube video. Is there any comments? Nope, no comments yet. Okay, it's good to hear everyone's following along. Okay, something that multiplies to give 12 and adds to give you 8 is probably 6 and 2. So we get x squared plus 6x plus 2x plus 12, and that would give you, right, yeah, that would give you x plus 6 and plus 2x plus 6. Yeah, which gives you, so yeah, the 2 would come out of that, right? So that would give you x plus 2, x plus 6. Okay, 29, x squared plus 3x minus 40. Okay, cool. So we need to get something that multiplies into 40, but also adds to give you 3. So we know that the positive number is bigger. So I'm probably going with, let's see, 7, no, 8. 8 and minus 5. Yes. 8 minus 5 gives you 3, and 8 multiplied by minus 5 gives you minus 40. So we have x squared plus 8x minus 5x minus 40. And that gives you x as a common factor for these two, and it would be x plus 8 minus 5, and you get x plus 8. The reason you get plus is because we've taken out the minus as a common factor. So we've taken the minus 5 as a common factor. So if you do minus 5 multiplied by 8 gives you 40. And this would end up with x minus 5 x plus 8. And that is the final. He's going to write 40. We're not even at 40 yet. Okay, 30th question coming up. X squared minus 8x plus 12. Interesting, isn't it? I suppose. Yeah. Okay, so we need to find something that multiplies to give 12 and adds to give you 8. I'm probably going to go with minus 6 and minus 2, because if you do minus 6 multiplied by minus 2, minus 6 cancel out, gives you 12. And if you add them both, so minus 6 plus minus 2, or just minus 6 minus 2 gives you, no, because minus 6 minus 2 will give you a positive response. No, minus 6 minus 2 give you negative. Yes. So, unless it was like multiplied, but it's not. So, minus 6 minus 2 is just, yeah, minus 8. So, that gives you x squared minus 6x minus 2x plus 12. And then you have x as a common factor, and you get x minus 6. And then you have 2 plus 2 as a common factor, and you get x minus 6. And that would give you x plus 2 x minus 6. I don't know why, but that does not seem to add up. Am I doing this right? Because I feel like I'm not. They're both supposed to be minuses. What has gone wrong there? So you get minus 6x minus 2x. And then you take out the x, and that gives you x, and then x minus 6. And you take out the 2. Take out the 2. Oh no, if I take out the 2, that would be minus x and 12. So that'll have to be minus 2. My bad. My bad. See? That did not seem right. So, yeah. Minus 2, minus 2. There you go. Much more simpler. And the reason I said that is because if I do minus 2 multiplied by minus 6, it should give me plus 12. Whereas previously what I had done, it was not giving me plus 12, it was giving me like a minus 12. So that was definitely wrong. But this is, I'm satisfied with this, and that's final. 31. Okay, so we have x squared plus 5x plus 6. Which, again, we have to look for something that's pretty simple. X squared plus 5x plus 6. Huh. Something that multiplies to give you 6 and adds to give you 5. That's interesting. Probably 3 and 2 though, isn't it? Yeah. So you have x squared plus 3x plus 2x plus 6. Yeah, sounds reasonable. 2 plus 3 is 5. 3 times 2 is 6. Well done. Well done. Yeah, so you get x as a common, and then you do x plus 3 plus 2 x plus 3 gives you x plus 3 as a common factor, and then x multiplied by x plus 2. There you go. That's 31. Oh, forgot that. 31, and now we have 32. 32. Is x squared minus 2x minus 24. Again, got to multiply to give you 24, and has to add to give you minus 2. I have to multiply to get you minus 24, sorry, my bad. So I'm probably thinking it's minus 6 and plus 4. So if you do x squared minus 6x plus 4x minus 24. And that would seem reasonable because you get minus 6 multiplied by 4 gives you minus 24. And minus 6 plus 4 gives you minus 2x. So again, same thing that we're doing. We're doing x as a common. We get x minus 6. And we take the 4 out plus 4 out. And we end with an x minus 6. There you go. And the common factor here is x minus 6 multiplied by x plus 4. Seems final. 33. x squared minus 3x minus 10 gives you, right, so you got to multiply something. I think it's minus 5 and 2, to be entirely honest. X squared minus 5x plus 2x minus 10. We end up with x as a common, x minus 5 in the brackets, and then plus 2 as a common, x minus 5 in the brackets. And you have x minus 5 as a common, and x plus 2. That looks final for that one. 34 x squared plus x minus 20. Okay, now that's a really interesting one, because we got to multiply to get 20, and we have to add to get 1. I'm probably thinking 4 times 5. Right, so the 5 would have to be greater, 4 would have to be minus. A little bit lower, yeah. So it would be x squared plus 5x minus 4x minus 20. Yep, sounds reasonable. And we take out the x as a common between these two, between x squared and 5x, and we have x plus 5 over there. And if we take out a minus 4 as a common, we end up with x plus 5 on that side. Yeah. And then if we take out x plus 5 as the common, we end up with x minus 4 on that side. There we go. 34, 35. 2x squared plus 5x plus 2. Yeah, so now I think it gets a little bit different, because we got to sort of find something that adds to give adds up to give 4. No, sorry, that multiplies to give 4 but adds to give 5. That's for the inner circle. So we end up with 2x squared plus 4x plus x plus 2. And I'm pretty sure I think we know where this is going. Okay, so we take out 2x squared as a common from this side, and we end up with 2x squared on that side, and inside we have is x plus 2. And on that side we don't have to do anything, we just get plus 1, x plus 2. Sounds reasonable? I think that does sound reasonable, yeah. And that equals 2x squared plus 1 with the common factor x plus 2. Right? I think this would definitely, because yeah, you multiply that, you get 2 on that side. You get 2x squared multiplied by x. Oh no, that's not going to be... Oh, I'm terribly sorry. No, that's not going to be an x squared. I feel like something was wrong with that equation, and I couldn't tell what it was, but yeah, this is definitely it. Not supposed to be 2 squared, because, you know, we take out 2x from there, that one doesn't have a squared, so won't be able to do it. Won't be able to do it. Yes. Okay, cool. Right, so that's final. If you appreciate it, yeah. Take a moment to step back and double check your working, because, you know, sometimes small things like that can make a really big difference, you know? I was going to say 2x squared plus 1. And I multiply, I was like, Even though that's pretty much common sense when you're working with quadratics, we'll find out later on as we keep working, of course. But, you know, it's always good to double check. 36. 3x squared plus 10x minus 8. Okay, something that multiplies to give 24, minus 24, my apologies, and adds to give 10. I think it's 12 and minus 2. So we get 3x squared plus 12, 12x minus 2x minus 8. Because you get minus 2 plus 12 gives you 10x. And 12 times 2 is minus 24, which is divided by 3, because, yeah. I still never understood why that is, but that's one of the ways that you work it out. I'm sure common sense would make sense, but yeah, for me it's a little bit weird. Okay, so let's take the common factors out. We have 3x on that side, which comes out, and we have x plus 4, I believe, on that side. And if we take out a minus, it's happening again. God damn it. If we take out a minus 2x, or just minus 2 actually. See, I don't understand what's going on. I'm going to sort this out at some point. Alright, we're just going to carry on with the other backup pen. So we get minus 2 on this side. Can't keep having that. Minus 2, and you get x minus, plus 4 on this side, because the minus is coming out. And that gives you 3x minus 2 as the common, and you get x plus 4 as the common. Okay, there you go. Let's do 37 as well. 5x squared minus 16x plus 3 should give you... what should it give you? Adds, multiplies to give you 15. Adds to give you minus 16. It's minus 15 and minus 1. 5x squared minus 15x minus x plus 3. Okay? And you would end up with 5x on the outside. You have x minus 3 over there. And if we take out a minus over there, minus 1, x, or just minus, no, it's just minus 1, sorry, my bad. Not x, because x is not there with 3. Take out a minus 1, and we take out a minus 1 from there as well, that changes sign, so you end up with x minus 3 on that side. And that would be equal to 5x minus 1 with x minus 3 as a common factor. Or in other terms, you would end up with x minus 3 with 5x minus 1 as the common factor. Somehow. Yeah, you basically end up with the same thing. 38. 6x squared minus 8x minus 8 gives you... Alright, so something that multiplies to give us 48 and adds to give you minus 8. 12 and 4? 12 times 4 is 48. So it's 12 times 4. So you get minus 12 and plus 4. Yep, that's definitely it. So you get 6x squared minus 12x plus 4x minus 8. You get 6x as the common. You get x minus 2 over there. That's correct. And you get plus 4 and then x minus 2. And that would end you up with 6x plus 4 with x minus 2 as the common factor. Yep, absolutely. 38, 39. You try fitting one more in over there. 15. 2x squared plus 7x minus 15 gives you... Right, so something that gives you minus 30, but adds to give you a 7. Probably thinking it's 10 and minus 3. Yeah, it's probably 10 and minus 3. 2x squared plus 10x minus 3x minus 15. It's weird because I've never actually understood that. And why would it multiply to give you that much? Okay, yeah, so moving on. Sorry. Had a blank moment. I was just literally just thinking. Probably should have been thinking out loud. But yeah, it's okay, cool. Alright, so we take out a 2x over there. 2x. And we get x plus 5 over there. We take out a minus 3 on this side. We get x plus 5 on the other side. So that would give you 2x minus 3 with x plus 5 as the common factor. And that's final. 39. Let's do 40 as well. To zoom in. 40. Yep. 2x to the 4. 2x to the 4. Wow, that's interesting. Plus 14x squared plus 24. Right. Now I'm going to do over here, I'm going to do something interesting. I'm going to take out x. Oh no, I can't take out x. But what can be done? It's quite interesting actually. Okay, so in this case, what I'm going to do is I'm going to state additionally. You can treat this as a quadratic as well, essentially, but the way that you would do that is you would substitute the term x squared. Okay, so I'm just going to say x squared is equal to y. Now, if I say y squared would obviously mean x squared squared, and that would give you 4. And y to the 0 would just give you 0. So if we do that, we can then easily say 2y squared plus, and bear in mind that this could be any alphabet. It could be either y, x, z. It's a variable. Okay, so we're saying x squared is a variable value, has a variable value of y, and yeah, so that'll be 14 14y, sorry, plus 24. And there's another interesting thing we can do is if we take out a common factor of 2, it would leave us with this, so which would imply, which would be, sorry, equal to 2y squared plus 7y plus 12. So that becomes much easier to work with. Now we just need to work out what y squared plus 7y plus 12 would simplify into, which would factorize into, not simplify, because we're doing the other way around, right? We need to factorize it. So something that multiplies and gives us 12, adds to give you 7 is probably 4 and 3, is most likely 4 and 3, it's definitely 4 and 3, is y squared plus 4y plus 3y plus 12. And that goes into y. If you take y as a common factor between these two, so you get y, which is y plus 4, and we take out plus 3 as a common factor over there, so we end up with y plus 4. And that would give you y plus 3 as the inside with a common factor of y plus 4. And now remember, we've got to substitute the original to x squared, right? So you would end up with, and obviously don't forget the common factor over there, 2. So you would end up with 2 x squared plus 3 x squared plus 4. And that is how you would simplify that equation. 41. Remember, don't just stick to the standard, whatever they're asking you to. Try to think outside the box. Like, what can you do to make it work your way? Because that's what mathematics is. You just have to bend. You have to bend whatever you know and the laws of whatever govern what you know into how you can make it work for yourself. Okay? 41. It's not 41. Oh no, it is 41. I don't know how is it 41. Let me just double check. No, it is 41. Right. Okay. So we have x squared minus 4. Now here's the thing, 4 is a square number. And so is this. This is also a square number. Now if I wanted to write this, I can also write this as this. So something that multiplies to give me 4. Multiplies to give me minus 4 and adds to give me 0. So if I write this out, I can probably write it down like this. So if I get x squared minus 2x plus 2x minus 4. And then what happens is if I put this down and if I simplify it, I can do it as x as the common factor. And you get x minus 2. And if I take out plus 2 as a common factor, you get x minus 2. And that would give you x plus 2 with x minus 2 as the common factor. Now what you would notice, which is very simplistic over here, is that you have the first term, which is a squared, okay, so that you get one of those. And you get the second term, which is a negative of a squared number, okay. So what happens is you basically end up with like opposites of the second term within the multiplied ones. I probably usually think that this is the easier way to work through it, but if you want to remember a direct way to get from here to there, just square root this number, okay, and split them into two different sort of terms, sort of factorized terms essentially, with the first term being common on each, and then you have positive on one side for the second term and a negative on the other side for the second one. This is called difference of the squares. It's an easy way to remember it, but that's how you get there. That's how you get from here to there. It's the longer way. It makes a little bit more sense. Possibly just easier to do that, to be entirely honest. 42. And remember, we're making up numbers over here because minus 2x and plus 2x never existed. Technically, I could have written a minus 3x and plus 3x, but that wouldn't have got me to sort of factorize it into these terms. So you have to use something that is beneficial to yourself to get you to a place where it's easier to manage numbers, essentially. So, number 42. Right, so here we go. X squared minus 49. Again, similar thing. So you get 49 is a square number, as in if you multiply 7 by 7, it gives you 49. So I can either literally just directly go, difference of the squares. So you get x plus 7 and x minus 7. But, you know, I know how that works. But it's always good to just show the working, because, you know, that's basically derivate. That's how people derived the difference of squares. That's how it works. So I'm probably gonna do it the long way. Yeah, it's much easier to do the short way. I'm just gonna do the long way so that people actually understand. So you get minus 7 plus 7x minus 49. You take x as common over here. You end up with x minus 7, and you take a plus 7 common on that side. You end up with x minus 7. And that will give you x plus 7 with a common factor of x minus 7. That's the final answer. Now I want to take a moment to actually delve into what would have happened if I would have done x squared minus 49, and if I would have said, okay, x squared minus 14x plus 14x minus 49, what would have happened there? Nothing. That's absolutely a valid equation because minus 14 and plus 14 cancel out. So I would still, this is still 100% equal to that. But having said that, you know, it's not useful. It's not useful to have this in the equation because I'm not getting anywhere from there. You know, there's nowhere else for me to go from there. So, which is why you need to have something that's useful for you. So if I use 7 instead, then, you know, it's much more useful. And this is the right way. And it will get you to something that you could, you know, then divide or multiply later on using factorization. But yeah, that's the reason why this makes more sense rather than this. 43. 4x squared minus 25. Okay, now so from now on I'm just going to do difference of the squares. I'm just going to say difference of the squares. Because of difference of squares, it goes into 2x minus 5 and 2x plus 5. And that's the final because of the difference of squares. 44. If you want, you can actually write it down because okay, yeah, makes it a little more sense. Okay, so 44, we have 9x squared minus 25y squared. Again, you don't have to be worried about this too much, but basically we can write 9x squared as 3x squared. Okay, and we can also write 25y squared as 5y squared. So it pretty much delves down to how you portray the image. So anyways, this, because of difference of squares, y squared, not g squared, y squared would be equal to 3x minus 25y and 3x plus 25y. 45. Now, see, you know, typically I would not explain. I would not give out these explanations, you know, like this or that. But because this is the first day of me doing it, I think I'm just sort of going with the flow. But normally these explanations would be given within our lecture, within the lecture series, which is usually held once a month. And we cover a specific topic and you know, try to get people to understand what are the ideas behind said topic. So we'll cover the explanation and definition within those lecture series, but we wouldn't actually cover the explanation within the workshop. We're literally just powering through lots of different questions, trying to find out if we can actually, if we have grabbed the concept, or if we have just sort of passed it by. Okay, so 36x squared minus 4. Again, this would end up with a 6x minus 2 and a 6x plus 2. Amazing, amazing. So now we have a tricky one, which is, I'll do that on the next page. 45, so it would be 46, isn't it? Yeah, 46. right? And that's 2x squared minus 50. Now bear in mind, 50 is not a squared number, so the only way you can simplify this is if we were to, I mean, 50 is a square, technically every number is a squared number, but you're not going to get any useful results if I try to do that. So for example, if I type in square root of 50 into this, which is just ridiculous. So if I type in square root of 50, it'll give me something like, 7.07 something. Okay, that's not useful as a decimal. Okay. Alternatively, what you can do is you can write it as a square root of that. So for example, technically the easiest way to simplify this, to sort of factorize this, sorry, would just be to do 2, and then you have x squared minus, oh no, you can't, no, you x squared minus 25. Okay. All right, and there you go. So now you do have a squared number, okay? And yeah, so I'm just gonna do it like 2 different ways. So let's say if I would have gone this way, you would end up with 2x squared minus 25, and that would bring you down to 2. Sorry, I'm just gonna write it down properly. Cool. 2x squared minus 25. Okay, and then you would end up with 2x plus 5, x minus 5. Okay, so having sort of looked at this, that's where you would end up based on difference of the squares. But alternatively, you could have actually even gone through it like this. Let's use a bit different color. Right, you could have actually gone through it like this, which is probably not the recommended way. But yeah, you could have gone through it like this, where you go 2x. Right, now this gets a little bit complicated. So you get x square root of 2 minus square root of 50. Okay. And then you have x. Yeah, it's probably going to take a long, it's probably easier to write it this way. So you get x square root of 2 plus square root of 50. And x square root of 2 minus square root of 50. And now these, like, both answers are absolutely correct, except for one of them is a little bit difficult to read. Do you get what I mean? Because it's just ridiculous. But furthermore, you could actually simplify this even further. So if we take out the square root of 2 on this side, so essentially we could write this as being equal to x square root of 20, square root of 2, sorry, plus square root of 2 multiplied by square root of 25. Do you get me? And then, of course, you have yeah, and then you have multiplied by x square root of 2 minus square root of 2 multiplied by square root of 25. Okay. So if you do that, yeah, of course you can do that, and you take out like a square root of 2 common factor from this portion of the equation, and you also take one out from this portion of the equation because they're both sort of separate, because that's a multiplied term. Do you know what I mean? That's a multiplied term. So you have square root of 2, which is common over here, comes out. Square root of 2, which is common over here, comes out as well. So you get square root of 2 squared, x plus 5, because the square root of 25 is 5, and x minus 25. Sorry, x minus 5. Because again, square root of 25 is 5. And that's how you end up with 2x plus 5 with common factor x minus 5. Exactly the same answers, different ways to write it. Of course, the easiest way is to take out the common factor first. The alternative way is to take out the common factor a bit later on. But that just basically shows that, you know, the idea behind the difference of squares actually works regardless of the method that you use. So yeah, essentially, yeah, that would work. Okay, we're gonna move on, and that was a little bit of too much explanation going into there. Yeah, that's the kind of stuff that we would normally cover in the lecture, but again, today's first day. I'm not sort of throwing around any important terminologies or anything, but yeah, we're just trying to get it done. Alright, so last two questions. We're gonna finish this, and then we're gonna call it a day, because we've pretty much done sort of math for a very long time now. I'm starting to get a little bit exhausted myself, and you know, I can only presume what you guys might be going through, because we're pretty much rushing through a lot of questions all at once. But yeah, that's what the workshop is about. It's just about sort of training your mind to focus on the math and getting it done as soon as, like, you know, in series, without sort of trying to take too many breaks. We're trying to get work done essentially as efficiently as we can. Okay, so trying to work through this one. We're just going to factorize this normally. So if we take the number 2 as the common factor, we can get 2. We get 3x squared minus 5x plus 2. Yeah, sounds reasonable. And if we try to decipher that one, yeah, something has to multiply to give us 6 and add up to give me minus 5. So it's probably going to be minus 6 plus 1. So if I leave the 2, no, you know what, just write the 2. 2, and we get 3x squared minus 6x plus x plus 2. Should then equal 2. And if I take a 3x as the common, we end up with x minus 2. Am I doing this right? Something does not add up. No. Because then I would end up with a plus 1, x plus 2. Right, and that's definitely not how it's supposed to work out. So if I get, it's a little bit weird, isn't it? Something has to multiply. No, I got the factors wrong. My apologies. Something has to multiply to give me 6 and add to give me minus 5. So that'll be minus 3 and minus 2, not minus 6 and plus 1. Yeah, no, that definitely did mess it up. Okay, let's try to do that one again. You know what? Let's try to embrace our mistakes. That's not right. Whoa. So we're gonna do that one again. So we do 2. Right, that's not right. And we're gonna do 3x squared minus 3x minus 2x plus 2, and that'll give you 3x x minus 1, and then you get minus 2, and you get x minus 1. enough brackets? Yes, absolutely. So we end up with 2 multiplied by 3x minus 2 with a common factor of x minus 1. And if we use the brackets correctly, you would see that that would equal 2, 3x minus 2, x minus 1. Awesome. 42. Last question for today. Yeah, we'll do some more workshops later on. If you enjoyed this one, please be sure to come back to the next one. 15x squared. 15x squared plus 42x minus 9. Again, if we're taking a 3 common factor, we end up with 3x squared plus 3 divided by 42. It's probably 16? No. Can't be 16. 18? No. 18? 18 times 3. No, it won't be 18. Probably 19. So 19 times 2. 3. No, definitely not 19 as well. 3 divided by 42 is 1, 4. 14. It's 14. Wow. What am I doing? See, tiredness isn't getting to me, so I need to take some rest as well. But I'll probably do it after this because I want to finish up. Minus 3. Wow. That took a while. I was thinking 19. How was I thinking 19? Okay, anyways, right. Doesn't matter. Let's get to it. Right, so we have... I doubt 3 would go again. No, 3 would definitely not go again. Okay, cool. So something that multiplies to give me minus 9 and something that adds to give me 14. Ooh, wow. That is definitely a head scratcher. Yeah. Absolutely. 100% head scratching. Scratching my head right now. Something that multiplies to give me minus 9, yet adds to give me 14. Oh my god. Again, look at what I just did. 3 common factor, 15, gives me 3. Wow. Does not give me 3, man. That should not have been giving me 3. It's a 5. I think it's literally just getting to my head now. Okay, now it's better. So something that multiplies to give me minus 15, but adds to give me 14. It's minus 15 and 1. Awesome. So we get 3 as a common factor. We get 5x squared plus 15x minus 3. Yeah, and that would equal 3, 5x as a common factor. We get x plus 3, and we get minus 1, and you get x plus 3. Another brackets. And yeah, so that would equal 3, 5x minus 1 with a common factor of x plus 3. Awesome. So that completes today's section. We did a few things. We did difference of 2 squares. We did a couple of quadratic equations. We learned how to sort of we didn't learn how to. We sort of simplified some expressions, expanded some expressions, and yeah, I hope you guys have had fun. We did a total of, let's see, 42 plus 56. We did 42 plus 56 questions. That's a total of 13 pages of work. Hope you guys had fun, and hopefully this puts into perspective how much time and effort it really takes to get work done. So don't worry. And of course, like I'm already on a prepared level. Like I've been doing math for pretty much most of my senior life. Most of the last few years, like I've been doing a lot of math. So, you know, hang in there, keep practicing. And once you get the core concepts, which we run through in our lectures, the Simply Learning Live lecture series, they definitely would help you do all of these questions a bit quicker once you have a good understanding of them. So take your time to try to understand them and try to see how much more practice you can get done. Of course, these are not the only textbooks that you can use. Use pretty much any textbook to give you, because they all cover the same concepts, the same core concepts. And yeah, I think that's pretty much all that I have to say for now. Do you have any questions for me? No? I'm going to stay on for another 2 or maybe 4 minutes if you have any questions for me. But until then, this was Simply Learning Live, the Core Mathematics Workshop Series. Thank you so much, everyone, for attending and watching this video. If you did like it, please do leave a thumbs up on YouTube as well. Or, yeah, just leave a thumbs up on Eventbrite. Leave a good review for it, and we can go through from there. Lovely. So I'm just going to do like a quick signature. Whoa, oh, way, oh, whoa. Yep, that's not coming out good. Let's try it a different way. So if I do, nope. Do that way, do pressure. There you go. Got to add in the live now. Woo! Yay. Okay, so we're actually going to start off from here itself, and yeah, we're going to move on from this point onwards. So for those of you that want to join us for the next workshop, you can do that. I think it's time. I don't think I've received any questions, so I hope you guys have had fun. Thank you so much for attending again, and hope you guys have a lovely the rest of your time. Until next time, signing off. This is Ank.